Hello student, good morning. Today I am going to discuss electronic configuration and molecular behavior. Last class I have discussed energy level diagram for molecular orbitals. Now I am continuing from the last class and discussing electronic configuration and molecular behavior. The distribution of electrons among various molecular orbitals is called the electronic configuration of the molecule. From the electronic configuration of the molecule, it is possible to get important information about the molecules as discussed below. Means now I am discussing stability of molecules. If Nb, capital N, small b, if Nb is the number of electron occupying bonding orbitals, B means bonding. If Nb is the number of electrons occupying bonding orbitals and Na, small a, and Na is the number occupying the anti-bonding orbitals. Na means a number of orbitals, not Na, number of electrons occupying the anti-bonding orbitals. Then what will happen? Then the molecule is stable. Molecule is stable if Nb is, Nb, B means bonding, Nb is greater than Na. And second, the molecule is unstable. The molecule is unstable if Nb is less than Na. This is important things I am telling you. The molecule is stable, again I am repeating, the molecule is stable if Nb is greater than Na, and the molecule is unstable if Nb is less than Na. This is the important condition regarding stability I have told you. And again you will understand, in bonding orbitals, if more bonding orbitals are occupied, in first case what I told you, the molecule is stable if Nb is greater than Na. It means what? More bonding orbitals are occupied, and so the bonding influence is stronger and a stable molecules results. And in second case, the anti-bonding influence is stronger. Anti-bonding influence is stronger, and therefore the molecules is unstable. Means in a simple way, if bonding influence is more, then molecules will be stable, and if anti-bonding influence is stronger, then molecule will be unstable. Now bound order. Already I have given and discussed in the previous classes about the bound order. Now this is the right time to discuss bound order. Bound order in shortcut BO, bound order, is defined as 1/2 of the difference between the number of electrons present in the bonding and the anti-bonding orbitals. it is very easy electronic configuration if you will write according to the M.O.T. According to molecular orbital theory, if you write the electronic configuration, then you have to count that in sigma how many total electrons are there, because sigma means bonding orbitals, and sigma star or pi star, correct, means a star means anti-bonding, without a star that is the bonding. This you have to understand. Without a star it is bonding, with a star anti-bonding. When you will write the electronic configuration according to the M.O.T, then just you have to count the number of electrons in anti-bonding or in bonding, means without a star orbitals, without a star how many electrons they have, and orbitals having a star how many electrons they have. Okay, that is called bonding electrons and anti-bonding electrons, means with a star anti-bonding, and without a star bonding. Then difference between the two divided by 2, that is called bond order, means bond order is equal to electrons present in bonding orbitals minus electrons present in anti-bonding divided by 2, that is called bond order. Actually, why it is divided by 2? Because in bond formation at least 2 electrons is required. In a single bond 2 electrons are required. That's why it is divided by 2. Then bond order is defined as the 1/2 the difference between the number of electrons present in bonding and the anti-bonding orbitals. Means you can tell half of NB minus NA. NB means number of bonding electrons. NA number of present in anti-bonding orbitals. Okay, NB minus NA divided by 2. The rules discussed what I told you now regarding the stability of the molecules can be rested in terms of, actually the whatever rules I have told you, that can be restated in terms of bond order as follows. A positive bond order, that is in that case NB must be greater than NA, means a stable molecule when NB is greater than NA means a stable molecules, while a negative means NB is less than NA or 0, then it means what? If NB is equal to NA or NB is less than NA, then bond order means an unstable molecule. All generally this NB will be greater, means number of bonding electrons will be greater than anti-bonding generally, but not necessary. Now I am telling about the nature of bond. Integral bond order values of 1, 2 or 3 correspond to single, double or triple bonds. Okay. Bond order 1 means what? It is a single bond. 2 means double bond. 3 means triple bonds. Bond order tells about the bond, number of bond. 1 means single, 2 means double, 3 means triple bonds, respectively. Okay. Now, bond length. Already we have discussed all the things. The bond order between the two atoms in a molecule may be taken as an approximate measure of the bond length. The bond length decreases as the bond order increases. This is very, very important, that as the bond number or bond order increases, and it means bond length decreases. Okay, or you can tell bond length decreases as bond order increases. Question is asked. Now I am going to tell about the magnetic nature. Magnetic nature. Here also question is asked. Magnetic nature. If all the molecular or vitals in a molecule are doubly occupied, the substance is diamagnetic, means two electrons are there, both are, means every orbital 2 electrons are there, no single, all are double, completely filled, then that type of molecule will be diamagnetic. Diamagnetic means it will be not attracted by magnet. Okay. If all the molecular or vitals in a molecule are doubly occupied, the substances is diamagnetic, because repelled by magnetic field. However, if one or more molecules or vitals are singly occupied, it is paramagnetic. Why? Because it is attracted by magnetic field. As for example, oxygen is paramagnetic. It is attracted by magnet, and diamagnetic means it will be not attracted, it will be repelled. Okay, that is the difference between these things, paramagnetic and diamagnetic. In diamagnetic, repulsion in magnetic field, it will be not attracted, but paramagnetic means it will be attracted, attraction will be there. That's example I given you, oxygen molecules. Now I am going to discuss very important and very interesting also. If you will understand, then you will enjoy in you can say calculating the bond order. How to calculate the bond order, that I am going to discuss. It is very interesting and mathematical. Quickly you can calculate and you will come to know that how many bond order is there between the two atoms. First thing. Second things, you can tell whether molecule is diamagnetic or paramagnetic very easily. Okay. Then now I am telling you that things. I am discussing that things. But I am discussing this for homonuclear diatomic molecules. In the case of homonuclear diatomic molecules, then first example I am giving you, hydrogen molecules. Here what you have to do, first you write, you can say electronic configuration of hydrogen. In case of atom you have written, in case of atom, but here you have to write in case of molecular orbital, M.O.T, according to M.O.T, both are similar. Yesterday means last class I have told you. Then it's these things, electronic configuration in a simple way. In the case of atom, you will writing 1s square. Here also same things you have to write, but only sigma term you have to add before 1s square, means sigma 1s square. Sigma 1s square means you can write sigma 1s and in a bracket and power 2 you write. Sigma 1s in bracket, small bracket, and power you write 2. Same meaning. It is just like 1s square. Now you are writing sigma 1s square or sigma 1s power 2. Same thing, same meaning. Then now only 2 electrons are there and it is filled. Hence, there is no question of anti-bonding because only 2 electrons were there and it is filled in sigma 1s only. Hence, no electron is left. Hence, in anti-bonding, 0. No electron is there. Then now, bond order will write NB minus Na divided by 2. Then NB, B means bonding. Then bonding electrons, 2 electrons are there, only sigma is written, no anti bond, no star. Then in NB is equal to now 2 electrons. Then you have written 2 minus 0 because no anti-bonding electrons. Okay, it is vacant, 0. Then 2 minus 0 divided by 2, that is called 1. 2 minus 0 divided by 2, that is equal to 1. It means hydrogen single bond is there. This means that the 2 hydrogen atoms are bonded together by a single covalent bond. Here I want to tell you, here you are for a molecule you are writing. There you were writing for atom. In general, for atom you were writing. Atom. Here you are writing for molecules. Then molecules, that also for homo. Then homo means here like N2, S2, then 2 will be there. 2 atom will be there. That's why 2 molecular orbital. That is the reason. In a general way, you were writing electronic configuration for atom. 1 atom. Now you are writing for molecule. That also for di-molecule. Di-atom means 1 molecule. Here, homonuclear. Example I given you, H2. Then that's why here you are considering bonding and anti-bonding, 2 molecular orbital. Always you have to consider both bonding and anti-bonding. Then here you have considered, in case of hydrogen, bonding 2 electron was there, in non-bonding no electron. Then 2 minus 0 divided by 2, that is equal to 1. This means that 2 hydrogen atoms are bonded together by a single covalent bond. The bond dissociation energy of hydrogen molecule has been found to be 438 kilojoule per mole and bond length is equal to 74 picometer. Both question is asked. That is the bond dissociation energy. Bond dissociation energy of hydrogen molecules mean HH bond. Then that is 438 kilojoule per mole because it is common. That's why question is asked. And its wavelength is equal to 74 picometer. Since no unpaired electron is there, a square is there. A square means 2 electrons are there. no single electron, no unpaired electron. That's why you can tell, because since no unpaired electron is present in hydrogen, molecule, therefore it is diamagnetic. Very easy to tell. No single electron, no unpaired electron. That's why it is diamagnetic. Hydrogen is diamagnetic. Now other example you can see, helium molecule, He2. And here in helium, how many electrons are there? Its electronic configuration. The electronic configuration of helium atom is 1s square. 1s square means He2 molecule you are considering, not the atom. Means here He2 means 2 atom of helium is there. There in one atom 2 electrons, then in 2 atom 4 electrons. In hydrogen you have taken 2, because in each hydrogen one electron was there. Each hydrogen has one electrons and total became 2. But in this case, helium case, 2 plus 2, 4 electrons you have to consider. Then now you have to write electronic configuration, keeping in mind bonding and anti-bonding. Then here how will you write? Then He2, just like S2 you have written electronic configuration, sigma 1s power 2, means 2 electron is you have used 2 electron. Total number electron in H2 was H2, not 1 atom, 2 atom molecule became 2. Here you are writing for He2 molecule, not the atom. Then here 4 electrons are there. Then how it will be filled? Then you will write just like hydrogen, what you have written same way. First you will write sigma 1s square, means 2 electron used up. Then next 2 electron where it will go? Then it will go to anti-bonding. That is the, now you will write sigma star 1s power 2. What you have written for sigma 1s, same way sigma 1s, only anti-bond you have to write, means sigma star before the 1s. Now you write sigma star power 2, sigma star 1s power 2, then 2 and 2, 4 electrons. Then now again you will fill it in the formula. Then here anti-bonding is 2. Anti-bonding electron is 2 and bonding is also 2. Then 2 minus 2 divided by 2, that is the 0. That's why He molecule is, helium molecule is therefore unstable and does not exist. He molecule does not exist because bond order is 2 minus 2 divided by 2, 0. That's why it does not exist. Similarly, it can be shown for beryllium also. Be2 also molecule you can show. Be, how many molecule? Be, what is its atomic number? Beryllium. Then it is 3. Then 3 plus 3, 6. Be2 you are considering 6. Then here same way, if you write electronic configuration, then you write sigma 1s square. After that anti-bonding means sigma star 1s square. 4 electron, 2 plus 2, 4. And after that you will write sigma 2s square. Sigma 2s square. And After that, sigma 2s we have used. Then anti-bonding 2s square. Then now see how many electrons it became. Lithium, helium atomic number is 2, lithium is 3, and beryllium is 4. Beryllium is 4, then 4 into 2, 8 electrons. 8 electrons. Then here 8 electrons, how will you fill? Then sigma 1s square, 2 electron, sigma star 1s square, 2 plus 2, 4, again sigma 2s square, 6 electron, and again sigma star 2s square, means 2 bonding sigma 1s square and sigma star 1s square, same way sigma 2s square and sigma star 2s square. Then now total, it became total electron, 2 plus 2, 4 to 6 to 8, 8 electrons. Then 8 electrons, then how many bonding electrons are there? How many anti-bonding? Then you count, bonding electron is 2 plus 2, 4, 4 and 2, 6. 6 bonding electrons. Sigma 1s square, 2 electron. And sigma 2s square, again 2 electron, 4 electron. 4 electron. And anti-bonding, again 4 electron. Sigma star 1s square and sigma star 2s square, means 4 minus 4 divided by 2. 4 minus 4 divided by 2. 0 by 2 means 0. Hence, this beryllium Be2 does not exist. 0 means does not exist. Now, I am coming for the next example, lithium molecules. Actually, these questions are asked in examination. You have to calculate, you have to tell how many bond order is there. In writing sometimes, in a written examination they will ask subjective, how will you calculate? But in objective, that concept is important. Now for lithium molecule, I am telling you, the lithium is 3. 3 into 2, 6. Li2 I am talking about. 6. Then 6 electron, again same way we will write sigma 1s square and again sigma star 1s square, means 4 electron, and again sigma 2s square, 6 electron. Then now bonding electron is now 4, anti-bonding is 2. Then 4 minus 2 divided by 2. That is a 2 divided by 2. That is the 1. Okay. From the here, then I told you 1. Bond order is 1, means single bond is there. It means that Li2 molecule, lithium molecule, is stable, and since it has no unpaired electron, all are 2 only. That's why it is diamagnetic. Okay. 4 minus 2 divided by 2 means 1, means single, one bond is there. Bond order is 1, single bond. It means that Li2 molecule is stable. And since it has no unpaired electron, it should be diamagnetic. Indeed, diamagnetic Li2 molecules are known to exist in the vapor phase. Li2 exists in vapor phase, keep in mind. Okay. Now next example I am giving you, that is for carbon molecule C2. Carbon molecule C2, not CO2, C2. Here you can see carbon atomic number is 6, then 6 into 2, 12. 6 plus 6, C2 is there, 12. Then how will you arrange? Then same way, same style. Sigma 1 square After that, anti sigma 1 square, 4 electron is over. Now sigma 2s square, anti sigma means sigma star 2s square. Then now again 4 is filled. Now pi will start. Pi 2p x, pi 2p x square, that is equal to pi 2p y square. Both are same energy. Then 4 electrons in this 2py. Then 4 electrons in 2p means 2p x square and 2p y square. But before 2p you write pi 2p x square and pi 2p y square. Okay, there are 4 electrons here in 2p and 4 electrons in sigma 2s and 4 electrons in sigma. Okay, then total it became how many? 6 plus 6, 12. Means 2 plus 2, 4, 2, 6, 8 and 8, 10. Again I am telling you that sigma 1s square is 2 and sigma star 1s square, then 4 electron. Now come to the 2s, sigma 2s square and sigma star 2s square means 4 plus 4, 8. And now come to the 2py, px and py, 2 to each. Then now it is a pi 2p x square, that is equal to pi 2p y square. Then 4 here, then 4 plus 4 plus 4, 3, 4 means 12 electron. Here in 2p case anti-bonding is not there, only bonding is there, hence no star. Only pi you have to write, not pi star, only pi. Then here you will see how many you can say bonding and non-bonding and n-bonding, anti-bondings are there. Then if you will count, then you will find 8 electrons are bonding. 8 bonding electrons are there and 4 anti-bonding. 8 electrons bonding. Just to count, then it will come like this only. Total 8 electrons in bonding means sigma 1s 2 and again sigma 2s 2 electron, then 4 electron, and again if you come to the pi, then all are bonding only 4 electron, then 4 plus 4 plus 4 sigma 1s 2 electron. After that sigma 2s square, that is 2 electron, 4, and p 4 electron, total 8 electrons. 8 electron bonding is 8 electrons and anti-bonding how much? Then sigma star 1 s square, that is a 2 electron, and sigma star 2s square. In 2s one is a bonding, another is anti-bonding, then only this 4. Then 8 minus 4 divided by 2 means 4 by 2 means 2. It means double bond is there. 2 bonds are existing in C2. The bond order of C2, that is 8 minus 4 divided by 2, that is equal to 2. And C2 should be diamagnetic because no unpaired electron, all are paired. That's why it is diamagnetic. Diamagnetic C2 molecules have indeed been detected. It is also found in vapor phase. C2 is also found in vapor phase. It is important to note that double bond in C2 contains of both pi bond and pi bonds because of the presence of 4 electrons in 2 pi molecular orbitals. Here sigma bond is also in C2. 2 bonds are there. One is sigma bond and other is pi bond because 2 pi orbitals are found there. Then I have told you about the this carbon C2 molecules. Okay, in most of the other molecules, a double bond is made up of a sigma bond and a pi bond. Generally, when two bonds are there, one bond will be sigma, other bond will be pi. In a similar fashion, the bonding of N2 means bonding in NO2 molecules can be discussed, can be written also, and you can calculate the bond also. How? Then now you can same way nitrogen also you can write. Okay, then in nitrogen into N is having atomic number 7, then 7 plus 7 14 are there. Then if you will write the electronic configuration, then there you will same way you have to write. Then you will find bond order is 3. Bond order is 3. Now I am telling you about oxygen. Oxygen, this is very, very important. That's why I am telling you. Then oxygen means O2 means 8 plus 8, 16 electrons are there. Only in this you can understand the nitrogen also, because in nitrogen 14 are there. 14 are there. Here 16s are there, 2 extra. Then now just I am telling you details, you can understand. Then here in case of oxygen molecule, electronic configuration you will write like the same way what you have written earlier. 16 you have to adjust. Then sigma 1 s square means 2 electron. Sigma star 1 s square. Then again 2, 4 electron is over. Sigma 2s square and sigma star 2s square. Again 4 electron is over. And 4 plus 4, 8 electron. Now sigma 2p z. Sigma 2p z I am talking. Z means sigma bond. Then sigma 2p z 2. Then now it became 4 plus 4, 8 plus 2, 10 electron. Now again 6 electron you have to adjust, 10 electron. After that 4 will go in x and y, px and py, 2. Then now it became 14, correct? Means px 2 electron, py 2 electron. But in this 2 you have to write pi 2 px square, that is equal to pi 2 py square. Then now 14 is over. Then here you will see all are fully filled. Hence fully filled, no unpaired electron. Then this is the case of nitrogen. That's why nitrogen is diamagnetic, no unpaired electron. But now extra 2 electron in case of oxygen you have to write. Then now here what will happen? Now you have written only bonding. P you have written only bonding. Bonding P you have written. Bonding pi 2 px square, that is equal to pi 2 py square. Now because bonding is filled, then it will go to anti-bonding, means a star you are using. Then pi star 2 px and pi star 2 py, according to the Hund rule, 1 electron will be filled. That's why pi anti-bonding means pi star 2 px1, that is equal to again pi star 2 py, 1 electron both. Then now it becomes 16. Then out of this 16, here you can see 2 electrons are unpaired. Then obviously unpaired means it will be magnetic. And now how many bond? Then if you will count the bond, then bonding electrons are 10 and anti-bonding, that is a 6. Then 10 minus 6 divided by 2, 4 divided by 2, that is the 2, means double bond. OO have double bond. Then here you can count how it became 10 or how it became 6. Then you can see sigma 1s square, 2 electron. Again sigma 2x square, 2 electron is 4 electron. Now sigma 2px, sigma 2pz, that is 2 electron. And now it becomes 6 electron. 6 electron, and after that 4 electron in 2px and 2py. That is the 10. And antibonding, then a star 1s square, that is 2 electron. After that sigma star 2s, sigma star 2s, 2 electron means 4 electron. And after that, and the end you have written sigma 2px1, sigma 2py1, 1 electron, then became 6. Then 10 minus 6 divided by 2, that is the 4 divided by 2, that is equal to 2. Hence oxygen is having oxygen, 2 bonds are there. In oxygen molecules are held by a double bond. Moreover, it may be noted that it consists 2 unpaired electrons. That's why it is paramagnetic. O2 molecule should be paramagnetic, a prediction that corresponds to the experimental observation. In this way, the theory successfully explains the paramagnetic nature of oxygen. Actually, for the oxygen, it was controversy that it was not clear cut that whether it is a diamagnetic or paramagnetic. They were thinking that should be, but not proof was there. But now, by use of molecular orbital theory, now it is successfully explained the paramagnetic nature of oxygen. Okay, then today I am stopping here. Now M.O.T. I have finished. Molecular orbital theory I have finished, and next class again we will meet. Thank you.